Right then, cloud gurus, the Kubernetes persistent volume subsystem. So often the cause of confusion, yet honestly, pretty simple. So let's nail the concepts and terminology. It all starts with the storage here. Portworx, NetApp, or file and block services from your cloud provider. These hook into Kubernetes via CSI plugins. Then on the Kubernetes side, we carve out volumes called persistent volumes or PVs. And a PV, right, has attributes like size. But we can also hook it into different tiers and the likes on the storage backends. So we're going to look at it here on Google Cloud in a second. And on the Google Cloud, a persistent disk, which is a block device, comes in one of two flavors, standard and SSD. Standard slow and SSD's faster. Well, we can hook into that through the GCE persistent disk plugin. And I get that this is Google specific, right? But it works the same with other plugins, yeah? They provide access to the different features offered by the storage systems. Anyway, that's a PV, a bunch of storage taken from a storage backend and made available inside the Kubernetes cluster. And it's all decoupled from pods, remember. So we create the PV on the cluster and it exists independently just like a pod or a node. Well, to use it, a pod needs a PV claim, a PVC. And again, like a node or a pod or a PV, yeah, a PVC is a resource in the API and an object on the cluster. So like a PV or a pod or whatever, we create it with a YAML file. And so long as these fields here match, then the two can bind. And the PVC will be like a ticket that a pod can use to say, hey, I want to use that PV. Talk is cheap though. Let's have a look. So I'm on a cluster here in Google again. And I've also got a manifest here called GKE PV.YAML. And look, it defines a PV. So, like we said, it is a proper resource in the API. We give it a name and then a spec. Now, ignore the access modes and the storage class name for now. We'll cover them later. Capacity 20 gig though. We get that. You know what? Ignore the reclaim policy as well. But this bit here says to use a GCE persistent disk called UberDisk, which, for this to work, already has to exist on my Google Cloud backend as a named volume called UberDisk, which if we look here, it does. Now, I fully appreciate this view is particular to Google Cloud, but you get the picture. It's an SSD, 20 gig, and a few attributes. And if you're on a different cloud platform or you're using a different storage backend, you know what? The concepts are the same. Well, you know what? No prizes for guessing, but we deploy it like normal with kubectl. Check that it's there. Alright, well, name and capacity. We're good with those. But go on, what's this access modes? Well, there's three basic ways a pod can access a volume. Read-write once, read-write many, and read-only many. And I think the names speak for themselves. Read-write once says it can be only mounted as read-write by one pod in the cluster. Read-write many? Yeah, that lets multiple pods write to it. And the same for read-only many, so multiple pods, but this time read-only access. Now then, not all volumes support all modes, and a single volume can only be opened in one mode at a time. So even if, let's say, a volume supports read-write once and read-write many, you cannot open it on one pod as read-write many and then on another as read-write once. Or you know what? I should say it can't have two active claims against it with different policies. Another thing though, as a general rule, it's only the file-based volumes like NFS or whatever that support read-write many. Don't be expecting your block volumes to be allowed as read-write many. Anyway, reclaim policy. Alright, this is what the cluster does when a claim on a volume is released. And for now, it's either retain or delete. Delete's probably the easy one. Release a claim on a volume and Kubernetes will delete it. And you know what? If it's supported, it'll delete it on the storage backend as well. Retain, on the other hand, that keeps the volume and its contents. So you can release a claim or, you know what, even delete or fail the pod that's using it, and the volume, including its data, that sticks around. Separate life cycles, yeah? Then if you need to delete a retained volume, it's a manual operation. Okay, back to here and now. There's no claim on it, and we'll talk about storage class in the next lesson. So we've got our PV, now we need a claim. Well again, yep, I've got a manifest for that. And again, look, it's a full-on resource in the API. Well, we give it a name. We know what access mode is all about. This has to match the PV if we want it to work. We're telling it here only to bind to PVs with the storage class name of SSD. More on this to come. And then we've got the capacity. So, for this claim to work against the PV we just created, access mode has to match. Tick. Storage class name has to match. Tick. And so does capacity. Tick. In fact, actually, the claim here can be for less than the capacity of the PV and the bind will still work. But if the claim's asking for more capacity than the PV, then it won't bind and the claim will sit there pending. Now, I recommend you play around with this, right? But if you do, the default reclaim policy is retain. So, if you release a claim on a volume and you want to reuse that volume with another claim, you need to delete the PV object and then recreate it. But that, I hope, has given you a pretty solid idea of PVs and PVCs. You start with your storage, an array or a cloud service. That plugs into Kubernetes. I'm on Google Kubernetes Engine, but it works the same in AWS and Azure or whatever you have. Then you create some devices or shares on that back end. And then it's a case of creating a PV that matches it. And it's the PV that makes the back-end storage actually a thing on the cluster. Then to use it, you create a claim that matches its attributes. Pretty simple. Oh, you know what? I've not shown you how to mount it in a pod. How bad is that? I don't know, I guess I got carried away with the fun. Well, real quick. I've got a pod definition here. I know, normally it'd be part of a deployment. Doesn't matter, right? The volume stuff's the same either way. Well, in the pod spec here, we're defining a volume, calling it data, and then using the claim object here that was already created. Remember, that claim's going back to a 20 gig SSD. Cool, so there's a volume defined. But then down here in the container that's going to run inside the pod, we're saying mount that data volume to /data in the container. And that's our volume in a pod, using a persistent volume claim to gain access to the 20 gig SSD persistent volume that we created, I don't know, 5 minutes ago. Magic! But you know what? It's all been a bit clunky and manual, yeah? Especially the pre-creating of the PV and then having to match it to this already created device on the back end. I don't know, it's just not screaming scalable, is it? Well, coming up next, we're going to see how storage classes make this all way more dynamic.